So hello students, how are you? So as we know, digital is going on in the live as well as Verilog is going on, as well as some Verilog quizzes are going on, digital quizzes are going on. So we have the limited free classes. So we have around 5 hours or 6 hour limited classes for every subject. After that, you have to purchase through the application. You can download our application, which is available on the Google Play App Store as well as on our website. So you can just download it. After that, in the application, you will get the pre-recording of all these faculties, detailed and complete classes. Detailed in the complete classes, plus some live sessions will be also there with the doubt clearing sessions, and everything is there in an unrestricted manner. But for the free of the cost, we can give you the limited access only, like 5 hours or 6 hours of every subject, but complete classes can't be a free of cost because we have the limited funds, very limited funds. So if you want to go for the free courses, you can watch the free classes. After that, you have to purchase our complete classes. You will get the access of multiple faculties there. Like uh, currently, digital is one faculty is taking Verilog by 2-3 faculties, digital by 2 faculties, Verilog by 3 faculties, ST by 2 faculties. Like that, you will get the multiple access of recordings as well as some live sessions will be also there. So it is a self-paced plus live sessions plus doubt clearing sessions. Everything is there. So yeah, Abhishek sir, you can
Yes, sir.
continue. Yeah.
Yes, sir.
So today, what will you will teach?
So
Boolean
today
algebra.
I will be starting the Boolean algebra part.
Okay.
Okay, and after that we will be covering K maps and
Yeah.
next other things,
Yeah.
number system and
Okay.
all
Okay.
in the future
Okay.
things.
Thank you.
Okay.
You can
Thanks.
continue. Thanks.
So hello everyone. So today we will be starting with our new topic, that is Boolean algebra. Fine. So what we'll be studying in this topic of Boolean algebra is that how we do the algebraic part, or how we will perform the various functions in the digital things. Fine. So let us start our topic. So first, okay. So first, coming to this slide. So in Boolean algebra thing, if you have to perform some basic operation, right? Here are some numbers written. So if you see that here it is written 1 plus 1. Here also there are many numbers written. Fine. So now I will explain you the basic functionality of all these. Why I have written these. Fine. So if we are performing what? If we are performing binary addition. Fine. If we are performing binary addition. If we are performing binary addition, then what will happen in binary addition case? If we are doing 1 plus 1, then what we will get? We will get 1 and 0, or you can say we will get 0 and 1 will be carry forwarded. Fine. So this we will get the result in case of the binary addition. Fine. Now if we are performing like in the normal mathematics, or you can say decimal addition or something like that. So what happens if we are performing the normal calculation? Then 1 plus 1, what we will get? 1 plus 1 will get 2. Fine. 1 plus 1, what we will get? We will get 2. This is the basic decimal addition, you can say. Fine. This is the basic decimal addition. Fine. Now why I have taken these two things? These two things I have taken. So binary addition I have explained you here also. Here also I will tell you this thing only, that if we are performing binary addition, what we will get? We will get 1 and 0. Fine. So this is for binary addition. This is for binary addition. This is for binary addition, and this is decimal addition. Decimal addition, or you can say, one second, decimal addition, or you can say normal addition. In case we are performing normal addition, then what we will get? We will get 1 plus 1 equals to 2. Fine. So these are the two things. Fine. Now if we are performing a logical OR operation, then what we will get? 1 ORed with 1 will get the result as 1 itself. We'll get the result as 1 itself. Fine. So this what it is? It is Boolean OR operation. it is Boolean or operation. Fine. Now, what we can conclude from here, it is that the first two things, these first two things, this gives us the numerical significance. This basically gives us the numerical significance. Numerical significance. This gives us the numerical significance, and this last part, what it gives, Boolean OR operation, it gives us the logical significance. Logical significance. Fine. So that is why now here from this, what you can understand that if we are taking understanding the numerical significance of 1 plus 2, it can also give us the answer as 2. This in this case, we are doing the decimal addition. Now if 1 plus 1, we are getting the answer as 1 0, then what it is normally the binary addition thing. And if we are getting 1 plus 1 equals to 1, this is a Boolean OR operation, or you can say the logical significance of this thing. Okay, now once you have the basic understanding or the rough idea of this thing, now what are the main things in the Boolean algebra? It is that we have various laws. Fine, we have various laws that I will be telling you one by one, and based on these laws, we can reduce our Boolean expression that we are getting. Okay, based on these laws, we can reduce our Boolean expression that we are getting. Fine. So before moving to the Boolean expression, fine, there are some Boolean operations. Fine. In the previous slide, I had told you now about Boolean operations. Fine. So here there are some Boolean operations. So what are these operations? If we are performing 0.0, what we will get? We will get 0. If we are performing 0.1 or 0 and with 1, then what we are getting? We are getting the result as 0. 1.0, we are getting the result as 1. 1.1, we are getting the result as, okay, so here I have done, okay, so this is wrong. Here what it will be? It will be 1. Fine. Or you can say 1.1 is equals to 1. Fine. 1.1 is equals to 1. Fine. Now, what is happening here? 0 plus 0 will give us 0. Fine. 0 plus 1 will give us 1. 0 plus 1 will give us 1. 1 plus 0 will give us 1. And 1 odd with 1 will give us 1. Fine. And complement of 0 is 1. And the complement of 0 is 1. And complement of 1 is 0. Fine. So these are the some basic Boolean operations that we are performing. Fine. Now, coming to the next thing. So we'll be starting with our laws. Fine. So first law in this Boolean algebra, what I am telling you about is the commutative law. Oh, fine. So what does the commutative law tells us? Commutative law tells us that if something is written like a plus b, then it is equivalent to b plus a. Okay. Logical significance you can understand of this expression is if there is a OR gate and we are giving two inputs, one is A and other is B, and whatever output we are getting here, we are getting you can say A plus B. Fine. This is logically equals to if at the first input we are giving B and at the second input we are giving A, then also we will get output B plus A, or these two things will perform the same basic function. Fine. So this is the commutative law. So commutative law is valid for OR gate. Commutative law is valid for the OR gate. Next, coming to the various functions where this commutative law is valid. Fine. So if something is written as A dot B, then it is equivalent to B dot A. Means commutative law is valid for AND operation also. Fine. For OR operation it is valid. Here for AND operation also it is valid. Now if A dot B whole complement is equals to B dot A whole complements, what it tells us that it is valid for NAND operation. Okay, it is valid for NAND operation. Fine. And A plus B whole complement is equals to B plus A whole complement means it is valid for NOR operation also. Fine. A XOR B is equals to B XOR A. A XOR B is equals to B XOR A. That means this commutative law is valid for XOR operation. It is valid for XOR operation also. Fine. A XOR B is equals to B XOR A. Means this commutative law is valid for XOR operation also. Fine. So what the conclusion we can draw from this slide is that commutative law is valid for all the basic operations and or the NAND, NOR, XOR and XNOR. For all these operations, commutative law is valid. Now coming to our next law. Next law is associative law. Fine. Next law is associative law. So what here first statement is written, if in the initially we are taking A plus B plus C means firstly if we are associating these two terms, fine, and in the next expression we are associating these two terms, and whatever result we are getting here means in first part, the same result we will get here in the second part. This is the associative law. Means in the first case we are associating B plus C means first we are ORing B and C, then we are XORing the result with A. In the next thing what we are doing, we are first ORing A and B and the result is ORed with C. Fine. I will explain you it with the logical gate expression also. Fine. So what is happening here, if there is OR gate and two inputs B and C are given and one input A, this whatsoever we are getting, it is A plus B plus C. Fine. This is equals to what we are getting from here. This is equals to A, B, and if we are taking C here, fine. So this is logically equals to this thing. Here also, whatsoever result we are getting, both these two results will be equal. Fine. This is the logical significance of this commutative law. This is the logical significance of this commutative law. Okay. Now in the similar way, means this commutative this is the logical significance of associative law. I'm so sorry. This is the logical significance of the associative law. Means this associative law is valid for the OR gate. Now coming to the second point, if A dot B dot C is written in this format, this is equivalent to A dot B and with C, means this associative law is valid for AND gate also. Now coming to the next thing, this A XOR in the bracket B XOR C is equivalent to A XOR B in the bracket XOR with C, means this associative law is valid for XOR gate also. Now coming to the fourth point, fourth point is A XOR B XOR with B XOR C is equal to A XOR B XOR with C. Fine. Means this associative law is valid for XOR gate also. So what we have got to know here, that associative law is valid for associative law is valid for OR gate, AND gate, XOR gate and the XNOR gate. Now what happened to the NAND and the NOR gate? So in case of the associative law, what we can find or what we can see, it's that this associative law is not valid for the NAND gate. Fine. This is the NAND gate functionality, and this is the NOR gate functionality. So associative law is not valid for universal gates NAND and NOR. So it means that this associative law is not valid for NAND and NOR. For fifth point, I am explaining you with the help of means what is the logical significance or what this thing is telling. I will explain you with the logical diagram. Fine. So what is happening here? If there is some NAND gate, fine. If there is some NAND gate, B and C are the inputs. B and C are the inputs. So what we are getting here? We are getting B dot C ka complement. Fine. And if we are taking A as the input here, and we are passing it with NAND gate then what output we are getting here? We will get A dot B dot C का complement का whole complement. Fine. We are getting this thing here. So, and what we are getting on the right hand side? On the right hand side, we are getting, we are taking A and B, pass it with AND gate, fine, and we are taking next C as the input. Now it is passed the resultant of this, and we are getting the output here as what we can say, AB dot C ka whole complement. So in the logical significance, these two things are not equal. In the logical significance, what we can see that these two things are not equivalent. Fine. So what we have got to know? We have got to know that associative law is not valid for the universal gates NAND and OR. Fine. Now coming to the next law. Next law is our distributive law. So what does the distributive law tells us? In distributive law, there are basically 2 points. In distributive laws, there are basically 2 points. If something is written in the format of A dot B odd with C, fine. So what will happen? This A will combine with B also, and this A will combine with C also. So in the resultant, what we'll get? We'll get AB, and this symbol means or symbol with AC. Fine. So if something is written in this format, in which format? If something is written in this format, then what we'll get? We'll get AB plus AC. Fine. And if something is written in this format, A plus BC, so what we can write it, its equivalent, it will be A plus B dot A plus C. Fine. Means here what will happen? A plus B. Now here the middle, here this sign is dot sign. A plus B dot A plus C. Fine. So this is the basic of distributive law, or you can remember these laws in this format. Fine. Now, what will happen? We'll see here. If it is written A plus B and A plus C, this what this will give? This is the means this is the this thing only. This is this thing only, and what it will give? It will give A plus BC. Fine. Now, if something is written P plus Q R N S, so what will happen with the help of the distributive law? It will become P plus Q in dot P plus R dot P plus S. Fine. Now, if something is written X plus Y dot X plus Z, what it will give? It will give X plus YZ. It will give us X plus YZ. I hope that till now you must be getting what is the distributive law. Now, if something is written A plus B plus C, A plus B C D, what it will give? It will give A plus B dot with A plus C dot with A plus D. Fine. So, we'll be getting these things here. Fine. I hope you might have understood it till now. What is the distributive law? Fine. Now, here is the proof of this thing. Here is the proof of this expression. Fine. So now what has happened here? Now x plus y dot x plus z. What we can do? We can take this x dot with this whole part. So it is written x dot x plus z plus y dot x plus z. Fine. Now after expanding it, what will get? X into x, that will become x only. X into z, xz. Y into x, xy. Y into z, yz. Fine. Now taking the x common, what we will get after taking the x common? 1 plus z plus y from these three terms plus yz remains the same. So 1 plus anything gives us 1. So it will become x plus yz. Okay. So this is the basic proof of this means this expression, or you can say this distributive law. Fine. Now I think you might have understood what is the distributive law. Fine. Now coming to the next thing. Next thing is very important law that is used in minimizing various Boolean expression, that is the consensus law. Fine. This is the consensus law. So first, before telling you about what is happening here and here, what I would tell you is what are the two basic requirements of these law. Fine. So first I would be telling you what are the two basic requirements of this law. What are the two basic requirements of this law. Fine. So first basic requirement is that it should be in the form of AB plus BC and AC. Means what it is telling us that if three variables are involved, fine, A, B and C, then it should be AB, BC and CA. Or if this is the SOP part and this is the POS part, this I would be just telling you in few minutes. Fine, what is the SOP and the POS form? Or if it is written in A plus B, B plus C and C plus A, fine. If the equation is existing in this format or this format, then we can apply the consensus law. And the second condition is any one variable should be in the normal form as well as complement form. Means if three variables are involved, then among these three variables there should be one variable that is present in the normal format and its complement should also be present here. Fine. Now first, here what is explained here, it is the first point. If the expression is present in the form of AB plus BC plus AC, fine. So what is happening here, AB plus B bar C plus AC, fine. So three variables are involved, and next what is happening, B is present and its complement B bar is also present, fine. Next what is happening is B is present and its complement B bar is also present. So what does the consensus law states, that if some equation is written in this format, AB plus B bar C plus AC, then what happens, the variable which is present in the normal format and in the complement format, that is remained that remains same, and the variable means the term except from these things is eliminated. So what we are getting here means, यहाँ पे क्या है, अगर B और B complement present है, fine. So जहाँ पे भी एक normal variable, wherever a normal variable and its complement is present, that terms remains in the final result, and the rest third term is eliminated. So this is what the basic consensus law. Fine. Now in the first we can see B and B complement are present. So in the result what we will get, AB plus B bar C. Now in the second example we can see, C is present, C bar and C is present. So these two terms will be present and this term will be eliminated, AB. So in the result we are getting BC plus AC bar. Now if in the third term, in the third example you can observe A is here and A bar is here, fine. So what is happening, these two terms will remain same and this will be eliminated. So in the result we are getting A bar B plus AC, fine. Now similarly, if the equation is present in this format, or you can say in the POS format, then we will be getting these things. Now I will explain you this also, fine. So here in the first example what you can observe, B is there and B bar is here, fine. So what will happen, this term and this term will remain and this term will be eliminated in the final result. So in the final result what we are getting, A plus B bar and B plus C, fine. Now coming to the next example, if we come to the next example, then what we can see, here what is happening, C is here and C bar is present, fine. One variable and its complement form is present here. So this term and this term will be present and this term will be eliminated. So in the result what we are getting, B plus C bar and A dot C, fine. Now coming to the third and the last example. So here what we can see, A is present and A bar is present, fine. Here what is present, here A is present and A bar is present. So what will happen, that these two terms means A bar B and AC would remain in the final answer and this term will be eliminated, fine. So for applying the consensus law, what you can see, what you can observe is that the two basic requirements of this law is that, means three variables should be present and equation should be in the format of AB plus BC plus AC, or if it is written in the POS form, then in this format, A plus B dot B plus C dot A plus C, fine. And after this thing, what should be present, any one variable should be in the normal form as well as the complement form. So the variable which is present in the normal form and as well as in the complement form, that variable will remain in the final, means after simplifying this left hand side, we'll get those two terms in the final result, and the third term which is left behind means that will be eliminated, or in which the, if in short you can say, means जहाँ पे एक नॉर्मल टर्म और एक कॉम्प्लीमेंट वाला वेरिएबल हमारा प्रेजेंट होगा, वही हमारे फाइनल एक्सप्रेशन में रहेंगे, ठीक है, एंड रेस्ट टर्म विल बी गेट एलिमिनेटेड, फाइन. So this is the basic of the consensus law. Now coming to the next law, that is the De Morgan's law, or you can say the De Morgan's theorem, fine. So this I had already explained you in previous classes also. Okay, so this is a very basic and you can say the most used law in the digital electronics. So what happens in the De Morgan's law? What happens in the De Morgan's law? That if something is written in the format of A plus B ka whole complement, then it is converted into A bar dot B bar, or you can say what is happening in the De Morgan's law, plus is converted into dot and dot is converted into plus, fine. Plus is converted into dot and dot is converted into plus, and the bar is splitted to individual variables, and the bar thing is splitted to the individual variable, fine. So now if it is written A plus B whole bar, then plus will be get converted to the dot thing. So dot is present here, and what will happen of the whole means this whole bar, it will be split, and it will be transferred to the individual variable. So it will become A bar dot B bar. Similarly, if something is written A dot B whole complement, fine, then what will happen? It will become A bar plus B bar, fine. So this is a very basic law, De Morgan's law. In this, what is happening? Plus variable is changed into dot. Sorry, plus sign is changed into dot, and dot sign is changed into plus, and the whole bar thing is divided or splitted to the individual variables. Now here what we can see, we can take the example also. Suppose if it is given A plus B plus C plus D plus E and so on, and whole complement is given, then what will happen? It will become, what it will become after applying the De Morgan's law? It will become A complement dot B complement dot C complement dot D complement dot E complement and so on, fine. So this will happen in this case. Now if it is written A dot B dot C dot E dot and dot so on, and whole complement is applied here, then what we will get here? What we will get here, it is A complement plus B complement plus C complement plus D complement plus E complement and plus so on, fine. So this is the thing that we will get in the De Morgan's law or in the De Morgan's theorem, fine. So this is the basic understanding of the De Morgan's law or the De Morgan's theorem, fine. So I hope you must have understood it, what is the De Morgan's law or what is the De Morgan's theorem, fine. Now coming to the next important thing, and that is principle of duality, fine. Next important thing is principle of duality, fine. So what does the principle of duality states? That before I should explain you what the principle of duality states, that first I will explain you how to find the dual of a function. Okay, how to find the dual of a function. So how to find a dual of a function? There are two basic rules, you can say. Before 0 dot is changed to plus symbol, and plus symbol is changed to dot symbol, means these two things are interchanged. If somewhere dot is present, you will change that into plus symbol, and if plus symbol is present, you will change it into dot symbol, fine. Next important thing, if 0 is present, it will be converted into 1, and if 1 is present, it will be converted into 0. So if 0 is present, it will be converted into 1, and if 1 is present, it will be converted into 0, fine. And if dot is present, it will be converted into plus symbol, and plus symbol would be converted into dot symbol, fine. So this is the basic of how to find a dual of a function. Fine. And what precaution you have to keep in mind? The precaution you have to keep in mind is, this is the main precaution that you have to keep in mind, that do not complement the variable. Means complement of the variable should not be taken. If 0 is present, it will be converted into 1, 1 converted to 0, dot converted to plus, plus converted to dot. Fine. And what precaution or what we should keep in mind is, we don't have to complement the variable. We don't have to complement the variable. Fine. Now, let us solve this example. So the here function f is given. So here function f is given, and we have to find the dual of this function. Fine. So how we can represent the dual of this function? How we'll represent the dual of this function? So we'll represent the dual of this function by f and small d over top. Fine. So what I had told you just now, if somewhere dot is present, it will be converted into plus, and plus would be converted into dot. Fine. So it would become a plus b dot of c plus d. Fine. So the dual of this function would be this thing. Fine. I hope this was very easy question, and you might have understood it till now. Fine. Now let me tell you what is the principle of duality. So principle of duality states that if there is any Boolean expression, fine, if there is any Boolean expression, and if we apply, if there is any Boolean, valid Boolean expression, fine, if there is any valid Boolean expression, and we apply duality on both sides of the Boolean expression, fine, then the final Boolean equation will also be valid. Means if some valid Boolean expression is given to us, and we find the dual expression, or if we find the dual of that function, and we apply this thing on both the sides, both means left and the right hand side of the valid Boolean expression, then the final result that we are getting, that will also be a valid Boolean equation. Fine. So I hope till now you might have understood it, what is the principle of duality. Now coming to the next concept, that is concept of the self-dual. Fine. Now coming to the next concept, that is the concept of the self-dual. Or okay, concept of the self-dual. Fine. So what we can see here is that one question is given: find the dual of f is equals to find the dual of f is equals to ab plus bc plus ac. Okay. So before solving this concept of self-dual, I would explain you one thing here, that I have told you, if there is any valid Boolean expression, and if we apply the duality on both sides, then we also get the valid Boolean equation. Fine. So let us consider one example of this. Let us consider one example of this. And the basic example we can consider is a odd with 1. What we get? We get 1. Fine. Now if in this equation we apply on applying a dual on both sides, on applying dual on both sides, what we are getting? So plus would be changed into dot, and 1 would be converted into 0. So what we will get? We will get a dot 0 is equals to 0. So this is also a valid Boolean expression. Fine. So this is also a valid Boolean expression. So this is basically what principle of duality is telling us. Fine. Now coming to the next thing, that is concept of self-dual. Fine. So here one question or the one function is given, that find the dual of this function ab plus bc plus ac. Okay. So what we have to do? We have to find the dual of this function. Fine. So what I have done on the first step, this function is written ab plus bc plus ac. Now when we have to find the dual of this function, dot will be converted into plus thing, plus symbol, and plus would be converted into dot symbol. Fine. So this would happen. Okay. So a dot b is converted into a plus b, and this plus is converted into dot, then b plus c. Okay. So here what I have done here, one mistake is done from my end. It would be dot. Fine. Dot a plus c. Fine. So this expression is basically, it is a plus b dot b plus c dot a plus c. Fine. Now next thing, what we will do, we'll solve this part. We'll solve this part. Fine, we'll solve this part. So a dot with b plus c and b dot with b plus c. Fine, and this dot is here, a plus c. Fine. So after solving, what we'll get, we'll get ab and ac from here. B dot b will give us b only, and bc here. AC is still the same. Fine. Now we'll expand this whole with the this. So a will come here, and then c would be multiplied with this whole expression. So a dot ab will give us ab, a dot ac will give us ac, a dot b will give us ab, a dot bc will give us abc. Now coming with the c, so we'll get ab dot c abc, ac dot c will get ac, b dot c will get bc, bc dot c will get bc only. Fine. So now from this step, what we have to do, whatsoever terms are repeating, we have to reduce them, or we have to write it only once. Fine. So AB is present here also. 1 second. AB is present here also, here also. So we have taken one AB. Okay. BC is present here also, here also. So we have taken one BC. AC is present here also and here also. So one AC and 2 times of ABC will give us ABC here only. Fine. So till now we have reduced our expression till here. Fine. So now after that, what we are doing, AB and BC is here only. We are taking A common from these two things. So AC common. After taking AC common, it will 1 plus B, it will give us 1 plus B, and 1 plus B, 1 plus anything gives us 1. So this will become 1. So in the result, what we'll get AB plus BC plus AC. Fine. In the result, what we are getting? In the result, what we are getting? We are getting AB plus BC plus AC. So if we'll observe, this was the function, and dual of this also, we are getting the same thing. Fine. So these types of function are called the self-dual function. These type of functions are called the self-dual function, where after performing the dual operation on the function and simplifying that equation, in the result we get the same function. Fine. So those type of functions are called the self-dual functions. Fine. So I guess you might have understood it till now, the concept of the self-duality. Fine. Okay.